Good morning. My name is Javier Sanz Cruzado. I am a postdoctoral researcher at the University of Glasgow, and I'm going to present this paper titled On Transaction-Based Metrics as a Proxy for Profitability of Financial Asset Recommendations. This paper is a joint work with Richard McCready, Greg McDonald and Ian Dunis from the University of Glasgow, and Nikos Droukas from National Bank of Greece. We initially presented this paper in the third international workshop on personalization and recommender systems in financial services at the Rexis 2022 conference. In this work, we compared two different perspectives on the evaluation of financial asset recommendations. The first one, considering how much money our customers could earn if they followed our recommendations. Second, the capability of recommendation approaches to predict future customers' investments. As mentioned before, in this work, we focus on the financial asset recommendation task. This kind of recommendation presents the customer a list of assets like stocks, bonds, or mutual funds, which they can acquire and later sell for money. The goal of financial asset recommendation is then to help customers increase the money they invest on those assets. An important factor of this kind of recommendation is that the value of the different assets changes over time. This is important not only for developing recommendation models, but also for evaluating them. Our work is focused on the evaluation of financial asset recommendations. But how can we do this? In this paper, we focus on two different evaluation perspectives. The first perspective, profitability performance evaluation, addresses the profitability this performance or profitability of the recommendation, or in other words, whether our customers would earn money from if they followed our recommendations. It is easy to see that this evaluation is aligned with the interests of the customers, earn money. However, it does not consider future customer actions. It does not take into account whether the customers do invest on the assets or not. Metrics for this perspective are commonly key performance indicators, average over the top K recommended assets, for instance, the return on investment or the net profit. The second perspective is based on the transactions of our customers. It tries to discern whether our recommendations are able to identify the future investments of our customers, predict on which assets they might be interested. Therefore, asset acquisitions are used as a signal of relevance here. However, this kind of information ignores the pricing information of the assets. Metrics that we use for this perspective include classical information retrieval or recommender systems metrics, like NDCG, precision, or recall. I want to note that in both perspectives, we usually look at a fixed time interval into the future. In the case of profitability, we measure the return of investment at, for example, 6 months in the future. And in the case of transaction-based metrics, we look at the transaction and the 6 following months to the recommendation time. Now, let's stop a moment to consider transaction-based metrics. As I mentioned before, transaction-based metrics ignore pricing information. But now, let's think what would happen if our customers invested intelligently, if they earn money with their investments. In this case, when we predict the future investments of our customers, we would be recommending profitable assets. Consequently, we would expect a high correlation between these two metrics, these two evaluation perspectives. In that case, transaction-based metrics should be superior. Why? Because they also consider the preferences of the customers, while providing information about the profitability of the recommendation. Because of this, we explore in this paper whether we can use transaction-based metrics and profitability-based evaluation without distinction for the evaluation of financial asset recommendations. In order to check this, we perform experiments over a dataset provided by the National Bank of Greece. This dataset is just a snapshot of the Greek market in the period between January 2018 and March 2021. Differently from previous financial asset recommendation datasets, which mostly provided pricing information about the assets, in this dataset, we also have customer investments, detailing buy and sell transactions between customers and financial assets. This is fundamental to be able to compare two different evaluation perspectives. In the slide, you can see some statistics about this dataset, number of financial assets, customers, or transactions. In our experiments, we want to study the two perspectives over a period of time to obtain robust results, not just on one point. Because of this, we will follow this experimental procedure. Okay, we in the slide just show the pricing data for the average pricing data for the different assets in our dataset, and we do the following. We first choose a time point, t, and we take all the information, time series and transactions before t as the training set, and the information in the following 6 months as test. Then the training data is used to learn the parameters of our models, and we generate a recommendation at time t. Then we evaluate that recommendation using the data in the test period. We start this from July 1st, 2019, and we repeat every 2 weeks until July 22, 2020, leading to 29 different time splits that we can use. Now, we want to compare the two different evaluation perspectives, and considering that, it is necessary to define suitable metrics for each of the perspectives. For the profitability-based evaluation, we use the average return on investment over the top 10 recommended assets. We look at the relative increase in value of the assets over a 6-month period. Then, for transaction-based evaluation, we rely on the classic NDCG metric, again, over the top 10 recommended assets. We use here asset acquisition, asset buys in the 6-month period following the recommendation, the test set, as relevant transactions. We consider different recommendation algorithms in our comparison. In particular, we consider two different families of algorithms. First, we consider a set of not personalized regression models, which aim to predict return on investment at 6 months into the future. We use here 3 methods: supervector regression, random forest, and light GBM. Then, as representatives of more classical recommendations, exploiting transactions between customers and assets, we use many algorithms. Random and popularity-based recommendation and not personalized baselines, collaborative filtering methods like GCN, matrix factorization, user-based KNN, or association mining, and a demographic user-based KNN method, which considers the answers of customers to a risk assessment questionnaire as features for determining how similar customers are. We can observe here the results of our experiments. The top row shows the transaction-based metric results, whereas the lower row shows the return on investment of the methods. We have divided the results on pricing-based models on the left and transaction-based models on the right. For each of the plots, the y-axis represents the value of the metric, while the x-axis shows the recommendation date. If we look at the results here, we observe the following. In the case of pricing-based methods, they have a very low value of NDCG, almost close to zero for most of the studied period. This is different from the transaction-based models, which they achieve much higher values of NDCG, reaching reasonable values at around 0.3 during the mid and end part of the studied period. When we look at the profitability, we observe the following. In the case of pricing-based methods, they have the performance sometimes fluctuates, but in general, they are able to beat the market at different points of time. This is not done in the case of transaction-based methods. There is a full interval of time where the models work very badly. They would make customers lose money when they invested on them. To recall, in this work, we wanted to see whether we could use one metric or the other without problem, by changing them without problem. However, as we can observe here, we start observing some difference between the two evaluation perspectives. Because of this, we decided to study whether there is a correlation between these metrics or not. For this, we took the average values for each algorithm and a split point and computed the Pearson correlation between the two metrics. The result of this correlation was that minus 0.22. This shows that not only our two perspectives are not positively correlated at all, but they are even negatively correlated. So if we recommend assets on which our customers might invest, we might be making them lose money. This gives the conclusion that we cannot exchange these two metrics, these two evaluation perspectives. But let us do a different question, which is, why is this correlation so negative? What does affect these transaction-based metrics that makes our correlation negative? And that's what we studied. In order to answer this question, we studied three different aspects in our work. First, we consider the effectiveness of the customers, whether they are able to earn money with their investments or not. Second, we consider the changing state of the market, whether the correlation is affected by global events like pandemic, wars, etc., which affect the state of the market. And third, we consider the effect that customers' investment strategy might have on the evaluation, on the correlation. The first thing that we consider is the effectiveness of our customers. As mentioned earlier, if our customers were just effective investors, we would expect a positive correlation between the metrics. But is this just the case in our data? To check this, we compare the market profitability with the profitability of the customer portfolios. In this screen, we plot in blue, from left to right, the average return at 6 months of the assets in the market, the median return, and the percentage of profitable assets. In red, we add the same values for the customer portfolios. As we can see from the plots, the red line representing the customer lies in general below the blue one representing the market. In the best case, which is the median, values are very, very similar. This indicates us that customers are unable to perform better than the market in our data, explaining to some extent the lack of correlation between return on investment and DCG when we look at 6 months into the future. The second reason that we consider are the market changes over time. In the screen, we show the average profitability at 6 months into the future. On the x-axis on the bottom, we show the recommendation date, and on the top, the date that we are predicting, the evaluation date. Looking at the evaluation dates, we can divide the studied period in 3 different sub-periods. The first sub-period, from January 2020 to March 2020, is a normal market period characterized by a slow growth of the market. The second period, from March 2020 to September 2020, is a period of great loss. We all know what happened in March 2020. The pandemic hit Europe, and it caused a great impact on the financial market, which led to a great loss period in the market. Finally, from September 2020 to January 2021, the market was characterized by a recovery period. A large growth of the market was observed during this period. We wanted to know whether the correlation between the different metrics might be affected by these changes in the market. So considering this, in this slide, we show the Pearson correlation between the two metrics by comparing the average metric values for each algorithm at each different time point. If we divide this period in the three that we saw before, we might observe the following. Okay, in period 1, we observe a mild correlation between minus 0.5 and 0.5. But however, when we move into period 2, the COVID period, correlation falls down almost to -1. Over the COVID period, recommendations with high DCG led to serious money losses. Then, in the third period, There is a slow growth of the Pearson correlation between the two metrics, which even ends in a very high correlation at the end, close to 0.7. This what shows is that indefinite, the market, the correlation between return and NDCG is clearly affected by changes in the market, like pandemics or wars, changes that modify the conditions of the market. Finally, we considered a third possibility. During our experiments, we considered 6 months as the investment horizon of our customers. However, we wonder if this was actually reasonable. To see this, we analyzed the average time our customers held their stock before selling them. In the x-axis of this figure, we show the average holding time for it, the average holding time of the assets, and on the y-axis, we show the percentage of customers which held them on average for that long. For example, an observation that we might do here is that, for example, only 22% of the customers hold their investments for less than 7 months. The thing here is that when customers hold their assets for a shorter or longer term than 6 months, the actual importance of their returns as 6 months metrics decreases because we are measuring something different that our customers want. However, NDCG, when we capture a transaction, we capture the whole range of investments. We don't know whether the customer is investing at 3 months, 6 months, or 12 months. But NDCG captures that. And that is something that provides another point of difference between the two metrics that we are considering. In conclusion, in this work, we have observed that we cannot use transaction-based metrics like NDCG in exchange of profitability-based metrics like return of investment. At some points, they are even negatively correlated, showing that identifying future customer investments might impact the earnings of our customers, the money our customers have. The reasons why these metrics are not aligned are diverse. First, customers might not be good investors, and they might underperform. They might perform under the market. Second, global events like pandemics or war can change the condition of the market and impact the profitability of the assets. And last, these metrics might not effectively capture the strategies of our customers. Considering this, we propose 2 recommendations for evaluating financial asset recommendation algorithms. First, when we evaluate financial asset recommendations, we should consider the changing market conditions so we can test the robustness and effectiveness of our approaches under the diverse circumstances. Second, we should consider that the actual investment strategies of our customer might act as a confounding factor for our evaluation, as we might be observing different time periods that our customers have. Thank you for your attention. I leave here QR code to access our paper and my contact date in case you have any questions about the paper or want to collaborate or whatever. Thank you very much for your attention.